Welcome to our presentation, which is about cost engineering for Core CM 510. Cost engineering is that area of engineering practice where engineering judgment and experience are utilized in the application of scientific principles and techniques to problems of cost estimation, cost control, business planning and management science, profitability analysis, and project management, planning, and scheduling. In other words, the art of approximating the probable cost of something based on information available at the time. Cost can be classified under two main categories: direct cost, labor, material, equipment, and subcontract. Indirect cost, taxes, risk, profit, contingency, and overhead. Direct cost, it can be defined as cost which can be directly attributed to a particular item of work or activity. Indirect cost, it can be defined as all those costs which do not become a final part of the installation, but are required for the orderly completion of the installation, and not limited to field/home office administration, direct supervision, capital tools and softwares, startup costs, fees, insurances, and taxes, etc. What is the difference between costing and pricing? Costing comes from the quantity takeoff and the information presented in the scope documents, the assignment of cost values to the elements of work and related items in the project. Pricing is the determination of the amount to be charged to the client/customer. Price is a function of cost plus profit and contingency. Price is inherent value of the product, project, or system to the client or customer. To determine the price, we must consider market share, competitiveness, and value. Despite that skills and knowledge of cost engineers are similar to those of quantity surveyors, however, the main difference between them is quantity surveying relates more to building design and construction, while cost engineering relates more to engineering projects and processes. However, cost engineers and quantity surveyors commonly work in both areas. Project management overlaps both quantity surveying and cost engineering in the project cost management area to some degree, but most project management functions are quite different from those of cost engineering and quantity surveying. Here are some of cost engineers' functions: estimates of capital or asset costs including development costs, estimates of operating and manufacturing costs through an asset's life cycle, risk assessment and analysis, trending of scope and cost changes, decision analysis, financial analysis, net present value, rate of return, etc. Project cost control. Cost estimation, an evaluation of all the costs of the elements of a project or effort, as defined by an agreed-upon scope. Estimates are required to establish basis for project scope, resources, revenue, margin, budget control, and funding requirements. We have three types of cost estimates represent various levels of reliability. The factors controlling the type of estimates are project scope definition, design availability, methodology, purpose, level of accuracy, and time. Conceptual estimates are ±30% accurate and are based on plant cost/capacity ratios and budgetary quotations for key items. Preliminary estimates are ±20% accurate and are based on site-specific information and key information of critical equipment and factored bulks. Definitive estimates are ±10% and are based on quoted equipment pricing, bulk tows, site-specific labor rates, and based on detailed construction plan. There are 5 methodologies available for estimating costs: expert opinion, analogy, parametric, engineering, actual. Considerations of estimating methodology. Choice of methodology is dependent upon type of system, software, hardware, etc. Phase of program, development, production, support. Available data. Historical data points from earlier system versions or similar system. Technical parameters of system. Expert opinion. Called Delphi method. Useful in assessing differences between past projects and new ones for which no historical precedent exists. Pros and cons. Steps of Delphi method. Example. Analogy. Estimates costs by comparing proposed programs with similar, previously completed programs for which historical data is available. Actual costs of similar existing system are adjusted for complexity, technical, or physical differences to derive new cost estimates. Analogies are used early in a program cycle when there is insufficient actual cost data to use as a detailed approach. Compares similarities and differences. Often use single historical data point. May have several analogy estimates of sub-elements to make up the total cost. It is good choice for a new system that is derived from an existing subsystem. Make sure actual cost data is available. A system where technology/programmatic assumptions have advanced beyond any existing cost estimating relationships CER. Secondary methodology/cross-check. Pros and cons. Steps. Example. Parametric. Utilizes statistical techniques called cost estimating relationships CER. Can be used prior to development. Typically employed at a higher CES level as details are not known. Most cases will require in-house development of CER. Pros and cons. Example. Engineering. Also referred to as bottoms-up or detailed method. Estimate is built up from the lowest level of system costs. Uses detailed cost element structure CES. Must include all components and functions. Can be used during development and production. Pros and cons. Steps. Example. Actual method. Bases future costs on recent historical costs of same system. Used later in development or production. Preferred method. Pros and cons. Example. This is the summary of the 5 methods